All right, so this is going to be a quick video on atomic radius, which is one of the many periodic trends that show organization of a trait across the periodic table. So this is in the next part of your notes. If you notice there's a snippet down here, it says atomic radius. So atomic radius, you should remember, hopefully from math, what a radius is. If you think about when you have a circle, okay, if you have a circle, if you go all the way through this circle, through the center of the circle, that's called a diameter, okay? Diameter goes through the center of the circle, and half of that is called a radius, all right? So atomic radius is half the distance between the nuclei, this is just plural for nucleus, okay, of identical atoms bonded together, okay? And there's a trend. In other words, as you move left to right on the periodic table and as you move up and down, there's a trend that has to do with atomic radius, basically how big it is, okay? That's really what we're talking about. How big is this atom, okay? Now the trends, you typically, I would want for you to kind of think about these and consider what you know already about the periodic table. So I'm going to erase. Remember, you can always pause this video. So I'm going to erase and I'm going to scoot my screen back up so I can see my periodic table. All right. So as you're looking at the periodic table, there's to be some things that at this point you already know. You should know how to determine the number of valence electrons, and you should be able to determine the number of rings, okay? So if you're thinking about the number of rings, okay, if you're thinking about the number of rings, as you remember the period number, which is right here, okay, the period number tells us the number of rings, okay? So if you are on the first period or the first row, you only have one ring. If you're on the second period or the second row, you have two rings, 3 rings, 4 rings, 5 rings, 6 and 7 rings, okay? So if we're thinking about how big something is, how big an atom is, you would think, hopefully, you should be able to tell me as you go down the periodic table, what is happening to the size of those atoms, okay? So if you're having a hard time thinking about that, think about it for a second. Now, let me go back. You should be able to tell me, does the size of the atom increase or does it decrease as you go down the periodic table, okay? Down meaning like this purple arrow. And so when we're talking about trends, we're always trying to figure out, is the trend increasing or decreasing as we go left or right, or is it increasing or decreasing as we go up or down? So back to atomic radius. Let's take lithium, for example, okay? Lithium, which is right here, all right? Lithium will have 2 rings. So I'm not going to draw a full Bohr diagram, but if this is his nucleus, okay? Lithium will have 2 rings, 1 ring, 2 rings. So let's just pretend this is lithium, okay? Now sodium, who's right under him, would also have a nucleus. We know they all have a nucleus, okay? But he would have 3 rings, 1 ring, 2 rings, 3 rings, okay? That's sodium, all right? And then if we went to potassium, he will also have a nucleus. And we know we don't draw a nucleus like this, but he would have 4 rings because he's on the 4th row. So 1 ring, 2 rings, 3 rings, 4 rings. So if we're talking about a radius, which is half of a diameter, you can see that the radius is getting bigger and bigger as we go down, okay? So our trend for atomic radius is it increases as you go down a group or a family. As you go down a group or a family, the atomic radius increases. So let's fill that in. Okay, this is usually the easier of the two to figure out. Okay, and I know my circles are still there, but that's okay. All right, so this one here, we're filling in B because this is going down a group. Okay, so the trend is it increases down a group due to what? It should be the number of rings. Okay, you can say rings. Remember, sometimes we call them energy levels. Sometimes we call them shells, whatever you want to call them. Okay, as long as you know all these names for them. All right, now, so hopefully that makes sense. It is a lot easier for you to remember the trend if you understand why it does what it does. For the longest, I could never get periodic trends down because I always tried to memorize increase and decrease, left, right, up, and down. And it's just, I mean, you only have two options, increase or decrease, so it can take a while. Give me 1 second. Okay, all right, so increases as you go down a group because you are increasing the number of shells or energy levels, okay? All right, so now let's talk about what happens as you go left to right across the periodic table. So now we're talking about what happens as you go from the left to the right, okay? Now this one's a little bit harder. I want you to think about it for a second. Tell me what you think would happen. Would that radius, so those same radius, would they get smaller or would they get bigger? Would it increase or decrease the size of that radius? And the thing is to think about, why does that happen? Why does that happen? So take a second, think about that. See if you can come up with some idea of what you think would happen. Okay, maybe you came up with an idea, maybe you did not. Now, if I had to guess, just based off of past experience, I would say that most of you said as you move towards the right, that the atomic radius would increase, that it would get bigger. That's what I would guess most of you guys said, okay? So let's look at an example and see if you are correct. Let's take someone who is on the same row or the same period. So let's do, how about we do nitrogen, oxygen, and fluorine, okay? Now, realistically, these are all on the same row. So their number of shells is going to be the same. So nitrogen is going to have 2 rings. So here's nitrogen. All right, he has 2 rings. And then you have oxygen, who has 2 rings. And you have fluorine, who has 2 rings. All right, so if you're thinking about it based off of rings, they look like they would be the same. So we can't use rings as a factor of whether it would increase or decrease. So now we got to think about what else is different. All right, well, their mass is different. Their number of electrons is probably different. And if we're thinking about number of electrons, that's usually based off of how many protons they have. Okay, so let's look at that for a second. Nitrogen has 7 protons. Oxygen has 8. Fluorine has 9. Now, if you understood your POGIL that you did the other day on Coulombic attraction, we talked about how there is an attraction between protons and electrons, okay? The electrons don't fall into the nucleus, but they are attracted because opposites attract, okay? Opposites attract. So if we're thinking about that, okay, that means their electrons for each of these would be attracted to the nucleus, okay? Which in some ways would kind of bring those rings in, bring in those rings or those shells closer, okay? So now if we're looking at this, if you think about it, fluorine has 9 protons, okay? He has the most protons. So if you think about protons, the attraction between protons and electrons as a magnet, Then fluorine has a stronger magnet, okay? A stronger magnet. And because he has a stronger magnet, that is going to bring in his rings even closer, okay? So they are going to, it's still going to be two rings, but those electrons on those rings are going to be even closer because they are attracted to that nucleus, okay? Which means that if we're thinking about nitrogen, who has the least number of protons, his ring may seem to be just a little bit further out. So his ring may be just the tiniest bit bigger, okay? So realistically, it sounds weird, but this is not the case. As you go across a period, okay, as you go across a period, the attraction between the protons and electrons, which are on the rings, increases. But because of that, that makes that nucleus, the radius smaller. So now if I look at this radius versus this one versus this one, it gets smaller. So as we go this way, atomic radius decreases. Okay, it decreases. All right, so atomic radius is going to decrease as you go to the right, So let's write that down in our notes. Okay. All right, so down here, what we're going to say is, when we're looking at atomic radius and we're looking at the trends, all right, it is going to decrease across a period due to increasing nuclear charge, which just means increasing, we can just say number of protons. But nuclear charge is just like, remember, this is acting like a magnet, okay? So if you want to put a note, you could say, as you, for example, we could say, as you go towards the right, bigger magnet. Okay, so it pulls rings in, pulls rings closer. All right, so in class we're going to do some practice problems, and that will be it for us for atomic radius.